Assalamualaikum. My name is Mama Irfan. My number matric is B12231059. And now I will present the lab file, which is fixed end and loose end. First, we go to fixed end. I will show the simulation about damping height and tension low. So the amplitude we go to 1 cm, frequency we put 2 Hz, damping 80% and tension is 20%. This is for fixed end for damping height and tension low. Next, we go for damping low and tension high. Damping we go to 20% and tension we go to 80%. As we can see on this simulation, the end of the string is tight or clamped, meaning that it cannot move up or down. When the wave reaches a fixed end, it will reflected back inverted, which means upside down. This reflection undergoes a 180 phase change. So we can see the fixed end become a null. Overall for fixed end, the end is stuck, so the wave will bounce back in the opposite direction. Next, we go for loose end. First, I will show for damping low and tension high. Next, I will show for damping high and tension low. The damping I put 80% and tension is 20%. Based on this simulation for loose end, it means the end of the string is free to move. When a wave reaches a loose end, it is reflected without inversion, and there is no phase change. Conclusion, the end can move, so the wave reflects normally without flipping. So that's all for my presentation. Thank you.
Okay, I have explained oscillate no end. Okay, we can see the amplitude is high 1.30 cm and for the high is and taper top increase wave energy, and we can see the frequency 0.50 Hz. The oscillation is low. You can see the wave is low and damping is at 80% and the height and energy is constantly lost to the surrounding, like you see, and higher damping causes the wave to die out faster, and tension is high and you can see higher wave speed, smooth and smooth wave action. It is a transit wave. How it is from left to right, and the propagates a transit wave under a no end condition. It allows to travel indefinitely without reflection. Okay, next I can explain the oscillate no end, and the next is the damping low and tension low. And we can see from the figure the wave propagate as a transverse traveling wave under a no end condition, allowing continuous energy transmission without reflection. the low frequency follows along with wavelength, while moderate damping causes occasional energy loss along the string. The measure wavelength and frequency calculation of wave speed, confirming the relationship between wavelength frequency and wave speed. See what happened to damping. That's all. Last in this layer, I can explain the standing wave, and you can see the form two waves of the same frequency, wavelength, and amplitude taking opposite direction and interfere with each other. And you can see the same is steady and direction, and the wave on the screen will show the occur due to the rotation and the end of the string. You see the steady plane, you can see the amplitude, the height is 1.20, and as you see frequency, you see and damping, steady and patient. That's nice. Thank you. That's how I got my thing. Bye.